Okay, so guys, I might have told you about two routers. Say I might have taken two routers. Most probably, I might have taken only two routers, R1 and R2. Okay, now I really don't remember the network. Maybe the usual networks that I take is 10.0.0.0/24. Okay, right, and 20.0.0.0/30 if I'm not wrong. Okay, and 30 dot 24 or 25. Okay, yes. Okay. Yes, guys. So now I told you that R1 will be having two networks in this routing table. Did I show it to you in the the packet tracer? Did I show the routing table in the packet tracer? Yes, right. So let me check whether I have saved the topology or not, or else I might have some. Okay, no, 8 a.m. 23. Okay, so might be, just give me a moment. Basic 2 p.m. 4. Okay, let it be. Okay, let me check which are the networks that are configured. Usually it will be the same. So it's a different one. Okay, so just give me a minute, guys. Just give me a minute. Yes, so this ought to be the diagram that I have shown to you now. So let me just configure, just give me a 1 minute so that I can configure the same networks in all the devices. The same thing, notepad, enable, or say just give me config t, then interface gig 0/0/0. So guys, just a moment. Okay, so if I'm not wrong, then I might have configured 10.0.0.1 here. Okay, /24, and this is 20.0.0.1/30, and this is 20.0.0.2/30, and this is 30.0.0.1/25, and this is 30.0.0.2, and this is 30.0.0.3, and this is 10.0.0.2, and this is 10.0.0.3. Okay, now, so did I tell you the concept of this one, gateway address? Gateway, no. Okay, so I suppose I might have just told you about this configuration. We'll start from that. Okay, just give me a minute while I configure it. So gig 0/0/0 IP address. So I suppose that you might have configured all the IP addresses and all, right? Okay, in the previous class when I have given you this topology, I suppose that you might have done it on your own. Okay, so I think you might know how to give the IP address and all. So I'll make it faster. 255.0 and no shut. Okay, interface serial 0/1/0 IP addresses 20.0.0.1, 255.255.255.252 and no shit. Okay, so sorry, let me just paste here. Okay, and here this router, it's 30.0.0.1/128 and 0/2/0 20.0.0.2. So the IP here is 0.2. Okay, so 10.2 and here it is 10.0.0.3. 30.002 and 3. Okay. Yes guys, now I suppose everything is done. Okay, so now if you check the routing table, sorry, okay, let me again share the recording, share the screen. So if you check the routing table of R2, okay, so which router it was here? I suppose it was Bangalore or Delhi. Which one it was? Delhi. Okay, so let me just give the host name as Delhi also here. Host name Delhi. Okay, and here host name is not necessary, but in order for us to understand, we'll be giving the host names. So host name, this is Bangalore. Okay, Bangalore. Okay, yes. Now guys, if you take a look at the Delhi router, do show. So I suppose I might have told you about the routing table as well. So show IP route. When you check, you got two networks connected to the router, which is 10.000/24 and 20.000/30. Okay, now when you take a look at this Bangalore router, you'll have do show IP route. You can see two networks, 20.000/30 and 30.000/25. Now I might have told you that we'll mention the unknown networks to the router. Now if I try to communicate, so from this computer to this computer, the communication happens because it is within the same network. Okay, now from this computer, if I communicate to this router also, it happens, or you will have the communication because that too is in the same network. Now if at all this computer wants to communicate to the outside network, whether it is this 20 dot network or whether it is 30 dot network, okay, so then for this computer you will have to mention something called the gateway. Okay, the default gateway address, which is the address of this router. Getting it? So here the gateway address is 10.0.0.1. So for these computers the gateway address is 10.0.0.1. So let me say configure the gateway address here, which is, so here you can see there's something called default gateway, which is 10.0.0.1. Okay, the same will be configured to this router as well. See here 10.0.0.1. Now for these computers the gateway address will be, what will be the, yes, 30.0.0.1. Yes. Now that I have configured the gateway address, so for communication you must need to set the IP address, the subnet mask, and also the gateway address. Clear? Okay. Yes.
Switching, sir.
CCNP. Who is taking the class? Okay. So now guys, let me again tell you. Now if you try to communicate from this computer to this computer, so from 10.0.0.2 to 30.0.0.2, when you try to communicate, both are in different network, right? So the packet will be sent to the gateway, that is the router. And now what the router will check is that the router will check the destination IP, which is 30.0.0.2, whether it knows about the 30 dot network. Now it doesn't know about the 30 dot network, it knows only the directly connected network, which is the 10.0.0.0/24 and 20.0.0.0/30. I suppose this is where we stopped. Am I right? Okay. Now we'll mention, so here also they got, say, the directly connected network, which is 20.0.0.0/30 and 30.0.0.0/25. Okay, now what we are going to do is we'll mention the unknown network to this router R1. which is the unknown network. For R1, the unknown network is 30 dot network. That is the unknown network. We'll mention that manually. Okay, so how to mention it manually? That's what we'll study it in the static routing, or in the static routing we'll mention the unknown networks manually. Okay, so we'll go to this router. We'll go to the Delhi router's config mode and we'll mention the command like this: IP root. IP root. Now IP root, then the unknown network address, which is 30.0.0.0. Then its subnet mask. What is the subnet mask? / 25 is the prefix length. So what is the subnet mask? 255.255.255.128. This is the subnet mask. Okay. Then we'll mention the exit interface. What we'll mention? We'll mention the exit interface. That means if at all the router receives a packet for this 30.0.0.0 network, the packet should be sent via this serial 0/1/0. That's the exit interface. Getting it? Okay, so we'll mention the exit interface, serial 0/1/0. Okay, so serial 0/1/0. Okay, there's a warning. We don't need to consider this. Okay, now when you check the routing table, the command is show IP root. You can see a root here which says S. What is S here? It says it's static. We have statically configured the unknown network to this router, and it says to send the packets to 30.0.0.0/25, send the packet via serial 0/1/0. Okay, now again, so here, now that you have mentioned the unknown network in R1. Okay, now we'll mention the unknown network in R2. What is the unknown network in R2? 20 dot. Is it 20 dot? 10 dot. Okay, because for R2 or for, say, I suppose Bangalore router, okay, for Bangalore router, this 10 dot it doesn't know about the 10 dot network. So that is the unknown network here. Okay, so we'll mention the 10 dot network in R2 or the Bangalore router. So we'll go to this Bangalore router, the command syntax is, we'll go to the config mode and we'll mention the command like this: IP root, then the unknown network address, which is 10.0.0.0, then 255.255.255.0, then the exit interface, which is serial 0/2/0. Getting it? Okay, so here we'll mention serial 0/2/0. Okay, here also there will be a warning. For now we don't need to consider. Okay, so here what happens is that now the R1 here, or the Delhi router, has got 3 routes in its routing table. Okay, so the first 2 are directly connected. So 10.0.0.0/24 is directly connected. Just give me a moment. And it is connected via gig 0/0/0. Then the next one is 20.0.0.0/30 via serial 0/1/0, and a new network which is, say, statically mentioned 30.0.0.0/25, that is also via serial 0/1/0. Okay, similarly for the Bangalore router as well. So it has got 2 directly connected networks, say 30 dot network via gig 0/0/0, then the 20 network. I'm not writing it completely. I hope you will get it. Okay, so now this 20 dot via serial 0/2/0, and say the 10.0.0.0/24 via again serial 0/2/0. Now when you send a packet from this computer to this computer, suppose the PC0 to PC2, what will be the source IP and the destination IP?
Destination 30.0.0.2.
Yes. So here it is 2 and here also it's 2. So the destination IP is 30.0.0.2 and the source IP is 10.0.0.2. Both are in different network. If they want to communicate to different network, the packet will be first sent to the gateway, the router. Okay, now the router will receive this packet via gig 0/0/0 and will check the destination, which is 30.0.0.2. It will check the routing table whether the 30 dot network is present in the routing table or not. Okay, so now it will check the routing table. Yes, of course, the 30 dot network is present in the routing table, and to send it via or send it to the 30 dot network, you should send the packet via serial 0/1/0. So the packet will be sent via this serial 0/1/0. Okay, now the packet will be reached at the Bangalore router. The Bangalore router will also check the same. It knows about the 30 dot network, which is directly connected, and it knows it is connected to gig 0/0/0 and will be sent via this interface, and hence this computer will receive this packet. Clear? Now again, the communication is not complete. The communication is complete only when the reply is received back to this computer. Okay, so now when the reply is generated, the reply will be generated by this PC2. So the source IP will be 30.0.0.2 and the destination IP will be 10.0.0.2. Both are again in different network, so the packet will be sent to the gateway, which is the Bangalore router. This Bangalore router will also check the same. Say suppose they'll check how whether they know about this destination IP or not. Of course they know it, and they will send the packet via serial 0/2/0. The packet will be sent via this interface, and the Delhi router will receive it, and the Delhi router will even check the same thing about 10 dot network. Say it knows about the 10 dot network, it is connected to gig 0/0/0, and the packet will be sent via gig 0/0, and this computer will receive it. This is the communication. This is the packet flow that happens between the machines.
What if we have more routers?
Of course, I'll give you the topology, no worries. Okay, so now, so this is the simple one, very simple one, only with the two routers. Okay, now,
Sir,
yes,
one small questions.
Yes.
Whenever 10.0.0.2 sending the packet to the Delhi router,
okay,
and Delhi router send the same to the Bangalore router. So once Bangalore router receive that packet, it will send through its gigabit 0/0/0, right?
yes.
Then both the computer will receive the same packet, right? PC2 and PC3.
Not really. Okay, not really. What happens is that, let me just tell you what is the process there. Okay, so what happens is that, let me now, I suppose everyone has got up to this much, what I've taught you, right? Okay, now let me just tell you about one thing. Now, what happens is that there's a journey. Okay, the journey is something like this. So the computer here, say the computer, of course, it works, say it is the machine or the end device machine, and we will interact, or whatever we do, say that will be, say, or we interact with the computer via the application layer, right? So whatever that you input, say the Microsoft Word, or say suppose whatever, let it be. Okay, so you interact with the application layer. Okay, so now the computer processes the data from layer 7 to layer 1. Okay, so from layer 7 to layer 1, it will process it, and via the layer 1, so finally I'll come to your question. So it's a journey. Okay, so now, so via the layer 1, the packet will be sent to the switch, and switch, you guys know switch is a layer 2 device. We haven't studied about anything about the switch, but just understand what happens is that when the switch receives it, it is receiving the data via L1, and now it will check it in layer 2. Switch is a layer 2 device, so it will check whatever the things, it will check it in layer 2. Okay, and it will forward, it will not check it in layer 3, it will forward it in layer 2 itself, and it will send it to the router. Okay, now again the router, what he will do is that the router will receive the message via L1, pass it to L2, then will process it in L3. Okay, then after checking the packet, after checking the destination, they'll again give it to L2. That means the packet will be again re-encapsulated by a data link layer header and a trailer. Okay, then via the L1 it will be again sent. Getting it? Now again this router does the same thing. It receives the packet via L1. It receives actually the bits only. It will process it to, or it will forward it to L2, then it will forward it to L3. In the L3, the say forwarding decision is taken by checking the routing table, then we'll be passing it to L2. So again the packet will be re-encapsulated. Okay, now then will be sent to L1. Okay, now coming to your question. Okay, now I told you, so this router will receive the packet via L1. Okay, then we'll construct it in a, or we'll rebuild it in the frame format. Okay, now what happens? So in the L1 you got the bits 1 0 1 1 0 0 0, like that. You got the bitwise thing only. Now they will reconstruct it as in the, say, frame format. And what happens is that, say, in the L2 they will check the data link layer header and the data link layer trailer. Okay, then they will de-encapsulate it and will give it to the network layer as the packet. Okay, so at this time the router processes the packet, the destination IP will be checked. The destination IP will be checked and it knows that the destination is available, or the destination is connected to gig 0/0/0. Then the packet will be forwarded to gig 0/0/0, where again they will re-encapsulate it with a data link layer header and a data link layer trailer. At this time they will check what type of layer 2 it is, or which protocol is used in layer 2. So what happens is that, say, this is Ethernet technology. This is Ethernet. So are you getting it, guys, or are you feeling confused? Getting it? So don't worry, if at all you are feeling confused, we'll again study it later. Okay, as he has asked the question, I was just explaining. Okay, so now in this Ethernet header you got the source MAC and destination MAC. Okay, so if he doesn't know the destination MAC of this computer, he is gonna send the ARP request and then he'll get back the ARP reply, and then he will send it only to this computer, not for this computer. He'll only send it to this PC2 only. Whoever has asked the question got it? Okay, for those who haven't understood it, okay, we will study it later, no worries. We'll study it later, in the sense I'll tell you with an example. Now that I don't want to mix it with these things. Okay, don't get confused. If at all you are confused, leave it. Leave everything. Okay.
Okay, sir.
Yes. Now guys, so now ultimately we are talking about the packet level. You do not need to check the frame level now. Okay, so now shall we ping from this computer to this computer? Okay, so now if you ping from this computer to this computer, so here let me go to the command prompt and ping. So ping 30.0.0.2. We'll see whether we are pinging or not. Did I tell you what is ping and all?
Yeah.
Okay, yes. So you can see the ping 30.0.0.2, pinging 30.0.0.2, and you are receiving the reply from 30.0.0.2. That means you have the connectivity from this computer, I mean from this 10 dot computer to the 30 dot network computer, because we have done the routing. Clear? Okay, now so you can see, say, send 4, receive 3. Now again if you send it, you will get 100% result. Okay, so now you can see send 4, received 4, lost 0% lost. That means whatever that we have sent, we have, say, received it back. The reply, we have received it back. And again, if at all you want to check the path of the packet, let me tell you how you can check the path. The command is trace route, trace rt 10.004, yes, to check the path. Okay, to check whichever path they are going, they are sending the packet. So you got a command called trace rt 30.0.0.2, which will reveal the path. You can see it is first going to 10.0.0.1, which is this router's interface, this Bangalore router's this interface. This is 10.0.0.1, and then it will be going to this router. So here it will be 20.0.0.2. We'll check it. Yes, it is 20.0.0.2, and finally to our computer, which is 30.0.0.2. So this is 30.0.0.2. Clear? So this is the packet flow. I suppose you have got it. Okay. Yes. Now guys, now shall I give you one more topology? Yes or no?
Yeah.
Okay, I'll draw it and I'll tell you the requirement. you will have to write down the commands only, I mean not the interface commands, the routing commands, the static route commands. Okay, so let me draw it here. Suppose you got 3 routers, R1, R2, R3. So guys, whenever you guys draw the router, you need to draw like this. This is the symbol of the router. Okay, sometimes I may be drawing just a circle, but you need to draw it completely. Now here you got a network. Say suppose this is serial 0/1/0, this is serial 0/1/1, this is serial 0/2/0, this is serial 0/1/0. Okay, now this is gig 0/0/1, this is gig 0/0/0, and again guys, .10 25.85.0/24 172.16.250.0/28 50.28.48.0/30. This is 100.250.250.0/30. So guys, just let me explain it and then you can note it down. Okay, so now here you got 3 routers. Okay, you can stop writing. Okay, I'll explain it and then you can write it. So here you got 3 routers here. Okay, so R1 is connected to a network, a LAN here, which is 10.25.85.0/24. Then R1 to R2 connection 50.28.48.0 here I have configured, say .1 here, and for R2 I have configured .2. Yes. Now for R2 again to the right side connection you got 100.50.50.0 .1 here and .2 here. Now so this is gig 0/0/0. So now here you got another network here, LAN 172.16.250.0/28. Now my requirement is to make these computers communicate to these computers. Okay, so my requirement is for this machine, the first and the second machine should communicate to the third and the fourth machine. Okay, so I need you to write down the commands, only the static root commands, the IP address and all. I suppose you know it. I have already taught you on say Friday, right? Say I want you to write down the commands, the routing commands for R1, R2 and R3. Okay, so now let me just tell you the command syntax here. The command syntax I've already mentioned, but again let me mention it one more time. We'll go to the config mode. So just give me a moment. The command is like this. Okay, we'll go to the routers, config mode. Okay, then we'll give the command IP root, then we'll mention the unknown network address, unknown network address, then it's subnet mask. Okay, then it's, yes, exit interface. Clear, guys? Okay, so now how much time do you need? Just 2-3 minutes. Take 5 minutes. Okay, no worries. And please ask if you have any doubts. And let me give you one more hint. To write down the commands, go with the packet flow. Okay, when you go with the packet flow, you will understand. Okay, yes.
Sir, done, sir.
What about others, guys? Everyone done? You guys are able to do it? No worries. Even if it's wrong also, no worries. This is the first time that you are doing, right? Okay. So again, You three, everyone's name I know, but still. Okay.
Srikanth.
Yeah, Srikanth. Okay, yeah, Srikanth. Okay.
There is two Srikanth.
Yeah, of course. And I was wondering, say, their names as well. See, this Srikanth also, I forgot this name. Okay, now, Kevin. Okay. Now, so guys, shall we discuss?
Yes, sir.
Or anyone still writing? Or needs time? There. Written. Okay. Then we'll discuss, guys. So, we'll discuss based on the packet flow. Okay. So, whenever, say, in the CCNA level, if you are able to explain the packet flow, then you are successful. Okay. So, now we'll go with the packet flow. Now, so here, this computer is participating in 10 dot network. And I told you that, say, this computer should be able to ping to this 172 network. Right. So this computer, say here, I'm giving an IP dot 2 here, dot 3, and here also dot 2 and dot 3 here. Now, so when this computer is trying to communicate to 172 network, say the packet will be sent. So first the gateway needs to be set. Okay, so remember you need to set the gateway address also, and the gateway address of this computer, what's the gateway address of this computer? 10.25.85.1. 2 is its own IP. Okay, 2 is its own IP, that's fine. Now I'm talking about the gateway address. Okay, so this is the network, right? And for these computers, say for these computers within this network, within this 10.25 network, if at all they want to send the packet to the outside world, or if they want to send the packet to the 50 or 100 dot or 172 dot network, say you need to send the packet to the router, and the router only will forward the packet. Got it? So the router's IP is the gateway address. Got it? Any doubts? Okay. Yes. Yes. Okay. So now, so for these computers, the gateway address will be 10.25.85.1. Okay. And what about the gateway address for these computers? The computers in 172 network.
172.16.250.1.
Yes, very good.
0/0/0/0.
Yes. 250.1 here. Okay. So 172.16.250.1. So that's the, say, IP address of this router. Okay. Now let me tell you. So the packet will be sent to this router first. The packet will be sent to R1 first. Okay. Now R1 will check the packet, whether it knows about the 172 network. Yes or no? No. By default, it doesn't know. By default, it only has 2 network in its routing table, 10 dot network and 50 dot network. Okay. So here in R1, you will have to mention the static route for 172 network. Okay. So what is the command for R1?
IP route 100.250.250.0.
Is it 100.250.250.0? So I told you, yes, it is unknown network information. Okay, I'll come to those things. Okay, I know. Okay, so now, so I told we can go with the packet flow. Okay, so now here for this R1 to send the packet. Okay, what happened? Yes, for R1 to send the packet to 172 network, the 172 must be defined in R1. Okay, so we'll define it like this. In R1, we'll go to the config mode of R1 and we'll define it like this. Okay, IP route, the network address is 172.16.250.0. Okay, then /28. So what is the subnet mask, guys?
40.
Yes, 255.255.255.40. 240. When you calculate it, it will be 240. So don't make mistake in that, guys, because that is an important thing. Okay, so now that, okay, it will be fine. Maybe in the next question onwards, that's going to be, so you have to make it correct. Okay, so for /28, the submask is 255.255.255.240. Okay, then we'll give the exit interface. So what is the exit interface?
Serial 0/1/0.
Okay, serial 0/1/0. Yes, this is for R1. So if you mention this command in R1, then the packet will be then forwarded via this serial 0/1/0. 0. Okay, and R2 will receive it. Now R2, so R2 will also check the destination IP whether it knows about the 172 network or not. Yes or no?
By default, doesn't know.
Yes, by default it doesn't know. So you will have to mention the command in
Add.
R2 also. And what is the command?
IP route
IP route.
IP, just give me a moment guys. R2, yes, config hash. Config hash will mention, yes, IP route.
172.16.250.0
Okay, 250.0. Yes.
is 255.255.255.240
240, yes.
Serial.
and serial 0/2/0.
Very good. CL 0/2/0. Getting it, guys? Now, the packet will be then sent via serial 0/2/0, thereby reaching the router R3. So now, R3, will it or does it know about 172.16 network?
Yes, it by default it is already there. It is connected.
Yes or no? Okay, I heard some no's.
R3 is directly connected.
Okay,
R3 is directly connected, so it
it's
knows.
directly connected and R3 knows about this network. Getting it, everyone?
Yes, yes.
Okay, there also. Okay, now so say it is directly connected network, so we'll send it to this computer. Now the reply packet. Now the reply is sent by 172 network to 10 dot network. So again here the gateway is set and the gateway will be dot 1. So the say as they are communicating to a different network, the packet will be sent to R3. Now R3 will check the packet. R3 will check and he'll understand the packet is for 10 dot network and whether R3 knows about this 10 dot network or not.
No, by default no.
Yes, by default it doesn't know about the 10 dot network. So for R3 you need to mention the command. Say what is the command here for R3?
RP route 10.25.85.0
Okay.
255.255.255.0
Okay.
and exit interface serial 0/1/0.
Yes. So again, let me say write it 10.25.85.0 255.255.255.0. Then the exit interface is serial
0/1/1.
0. It's 0/1/0.
Sorry, 0/0.
Okay, for R3. For R3, you need to send the packet via serial 0/1/0.
0.
Getting it?
Yes, sir.
Now the packet will be received at R2 now. Okay, and R2 will also check the same whether it knows about the 10 dot network or not. Whether it knows
No,
about
by default no.
no. Okay. Yes or no?
We have to add. We have to add.
Okay. It doesn't know. By default, it doesn't know. By default, R2 knows only about the 50 dot network, 100 dot network, and also the 172 network after we have mentioned it statically. Okay. So here R2 doesn't know about the 10 dot network that need to be mentioned in the R2 as well. So here we'll mention that in R2. So the command syntax here it will be for R2. What is the command syntax, guys?
IP route 10.25.85.0 255.255.255.0
Okay.
serial 0/1/1.
Everyone getting it? Okay. Serial
0/1/1.
1. Okay, because for 10 dot network, say you need to send the packet via serial 0/1/1, and R1 will receive it, and R1 will send the packet to this computer because this network is directly connected to the computer. Everyone fine?
So what about the serial and kick? I don't understand that.
What about the serial and which serial and which kick?
No, I don't understand why we are using that serial and kick.
This serial and this kick. I told you that the serial interface is say for lease line connection and for those WAN connections we'll be using the serial interface. Okay, and Ethernet say we use it in the LAN interface. Clear?
And we are using Ethernet.
Ethernet.
So that serial is
Yes. No. The serial for WAN.
WAN. Okay.
Okay. Yes. Everyone clear? Having doubts? Sure?
So gig is for Ethernet.
Yeah, gig means gigabit Ethernet.
Okay.
Right. So Ethernet itself, I say you got different ones. Say fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet, like that.
Now I got it.
Okay. Yes. Now guys, now everyone has understood this thing. Now my requirement. So here today this is the task. So this is the task. So implement this in your, say, in your Cisco packet trace or GNS or whichever software it is, you can implement it. Okay. Then, so my first requirement is that these computers in 10 dot network should communicate with the computers in 172 network. The second requirement, let me tell you about the second requirement. Okay, we'll not discuss it. Think about it and try to do it yourself. Okay, so this computer, so my second requirement is that this computer, that is 10 dot, the computers in this 10 dot network. So the 10 dot network computers, say network 10 computers, okay, should ping here, should ping to 10 dot, sorry, say first check the connectivity. First check the connectivity. Check the connectivity from this 10 dot network to, I mean these computers, to this IP 100.250.250.2. Okay, now if you didn't get the connectivity, if it's not pinging, find out the reason why it's not pinging. Okay, and make them ping. Getting it? Again, go with the packet flow. It is very easy. Okay, again, next thing, one more thing, the third requirement. The computers from this 172 network should ping this one, 50.28.48.1 here. It should ping this network. Okay, now if at all it's not pinging, find out what is the reason why it's not pinging, and you should be able to get the connectivity. Okay, do whatever you want to get the connectivity. Clear, guys?
Yes,
Okay.
sir.
Yes. So that's the task for today. Now shall we go to the next thing?
Yes.
Okay. Yes. Now we'll go to something called a route selection, or again, before route selection, again one more thing. Static route using next hop address. Okay, so far we have studied the static route, it's the static route itself, but static route using, previously we have studied static route using exit interface. We have just mentioned the exit interface. Now we'll mention, or we'll study about the static route using next hop address. Okay, you can write the heading static route using next hop address. Okay, now in static route using next hop address, so yes, here in R1 the command was like this. Okay, so IP route 172.16.250.0, 250, whatever is the subnet mask, we have mentioned it, and then the exit interface is mentioned. Now if you're going with the next one, instead of mentioning the exit interface, you are mentioning something called next hop address. Instead of this exit interface, you will mention next hop address. Next hop address means the next router's IP address. What is it? It's the next router's IP address. Okay, so you can mention it like this also. Okay, so in R1, to go to 172.16.250.network, either you can mention it, go via serial 0/1/0, or you can mention it, or you can mention this IP address 50.28.48.2. Okay, so the command syntax will be like this. Okay, instead of mentioning the serial here, we'll mention the command, say 50.28.48.2. Clear, guys? So it's just tells, or it just tell the router to go via this 50 dot network, or to send the packets to the 50 dot network. If at all he wants to send the packet to 172 network, send the packet to 50 network first. I'll explain it, no worries. Now, so here in the previous diagram, okay, in the previous diagram, let me just take away the static route commands. Show run, you know about show run, right? Show run is to view the running configuration, and if you execute the show run, you can see lot of things here. Okay, of which one command is the static routing. Okay, if you only want to see the static routing commands, you can customize it. Show run pipe section. Okay, you are looking for that particular section called IP route. Okay, it shows you the particular command. Okay, so let me delete this command. Okay, and let me delete this command as well. To show run pipe section IP route. Okay, I've deleted all the static route commands. Okay, so if you take a look, do show IP route, you can only see the directly connected network. 20 dot network is directly connected, 30 dot network is directly connected. Same thing here for this router as well. Do show IP route. You can see, say 10 dot network is directly connected, 20 dot network is directly connected. We do not have any static routes. Now, instead of mentioning the exit interface, I am mentioning what I am mentioning, the next hop address. Okay, so now I am telling, say, here I have given the IP addresses like this. Here 10.0.0.1, here it is 20.0.0.1, here it is 20.0.0.2, and here it is 30.0.0.1. Okay, now you can listen here. We'll go to the Delhi router and we'll mention the command like this: IP route. The command is the unknown network, which is 30.0.0.0. Then the subnet mask is 255.255.255.128. Then instead of the exit interface, say which is serial 0/1/0, instead of that exit interface, we'll mention the next router's IP address, which is 20.0.0.2. Shall we mention it? Yes or no?
Yes.
Okay, so here we'll go to the Delhi router. We'll mention the command like this: IP route 30.0.0.0, 255.255.255.0, 20.0. Yeah, 128. Yes, guys, 128 because it's /25. Okay, and then 20.0.0.2, the IP address of the next router. Okay, now when you take a look at it, do show IP route. You can see the static route. Say to go to 30.0.0.0/25, the packet needs to be sent by 20.0.0.2. Okay, now again the next one. So here, okay, now this Bangalore router doesn't know about this 10 dot network. If the Bangalore router doesn't know about the 10 dot network, it can be mentioned like this: IP route 10.0.0.0, then 255.255.255.0. Then instead of mentioning this exit interface, we can mention the next hop address, which is the IP address of the next router, which is 20.0.0.1. Clear? Okay, so I'm gonna mention this command in the Bangalore router here. Config mode, the command is IP route, say 10.0.0.0, 255.255.255.0, then 20.0.0.1. Clear? Then let me tell you what happens. So now when the router receives a packet, when he is sending the packet for this 30 dot network, the packet will be sent to the router, and the router, what he will do is that he will check the routing table. So whenever he receives a packet for 30 dot network, he'll check the routing table. Of course, the network is present in the routing table. Then say he will check how to send the packet to 30 dot network. So he knows the packet needs to be, to send the packet to 30 dot network, it needs to first send the packet to 20.0.0.2. Then the router will again check how to go to 20 dot network. So 20 dot network is directly connected to, so here you got how to go to 20 dot network. Another entry is there. To go to 20 dot network or to send the packet to 20 dot network, send it via serial 0/1/0. Clear, guys? So the packet will be sent by 1/1/0. So the router will have to say take a look at the routing table twice. Right? The first time how to go to 30 dot network. He understood to go to 30 dot network, the packet needs to be sent to 20 dot network. Then how to go to 20 dot network? So to go to 20 dot network, the packet needs to be sent to serial 0/1/0. Getting it? So if you mention the next hop address, the router will have to take a look at the routing table multiple times. Okay, so maybe twice or maybe thrice or 4 times or 5 times, like that. Okay, and if at all the root lookup, say the router is looking at the routing table multiple times, then that is called recursive routing. What is it called? Recursive routing. Clear? Okay.
Can you just repeat once more?
Yeah, no issues. Okay, so whenever a packet is received for 30.002 or 30.003 or say 30 dot network, this router, the daily router, will check the routing table whether it has got 30 dot network or not. Yes, it has got 30 dot network. Now it will check how to send the packet to 30 dot network. It will understand the packet first needs to be sent to 20 dot network. Then the router will again check how to go to this 20 dot network. So to go to 20 dot network, you need to send the packet to serial 0/1/0. So then the packet will be sent via serial 0/1/0. So the router has checked the routing table 2 times, more than once. So that's why it's called, or that is why, yes, it's called recursive routing. Clear? Okay. So this is the process that happens. Any doubt? Okay. Now, so this is it. Now we'll go with one more thing. Okay. Now we'll go with something called default routing. So you can write the next thing called default routing. Okay. Yes. So default routing is usually done in the end routers. It is usually done in the end routers. Okay. Usually. Okay. Or for now, just understand that one. It is also done in the in-between devices as well, but for now, just understand it is done in the end devices only. End device means in the end routers. Okay. Now, let me tell you what is default routing. Suppose if you got, say this is your home router, your Wi-Fi or wired router, whatever it is, your wired modem or Wi-Fi router, like that. Okay. Now you might have connected, if it's a Wi-Fi router or something, then you might have connected it to the phone, or you might have connected it to the computer, then you might have connected it to the laptop. So you will have different devices, right? From the computer or from the laptop or from the mobile device, you can access multiple websites, right? You can access, say suppose the connection is like this. So from the Wi-Fi router, we have connected it to the ISP router, the internet service provider router. Okay. Now from the ISP router, we can get it connected to the Google, you can connect it to Facebook, you can connect it to Yahoo, you can connect it to Twitter, you can connect it to say whichever you want. Okay, you can connect it to multiple sites. So in this router, suppose the Google's IP is 1.1.1.1, okay, and the Facebook's IP is 2.2.2.2, and Yahoo's IP is 3.3.3.3, and Twitter's IP 4.4.4, and say some other YouTube's IP is 5. Okay, so you got multiple IPs here. So here we need to mention each and every route to this router, which is really very difficult, or it's unnecessary here, because our router will not, there are two things. Again, it is difficult for us to configure all the routes here. 1 dot network, 2 dot network, 3 dot, 4 dot, 5 dot, 6 dot, all the networks you need to configure. Again, this router is a small device. It's not a very big router and all, and it can't accept that much, say, routes in the routing table. So what we will do is that we will configure what is called default routing. We'll configure what is called default. Yes, like a gateway. That means if at all he wants to send anything to, or he wants to send anything to some unknown network, or whatever be the unknown network, just forward it to the service provider router. That's the default routing. Getting it? Okay, so if it's 1 dot network, 2 dot network, 3 dot, 4 dot, 5 dot, 6 dot, 7 dot, 8 dot, it doesn't matter at all. Whatever be the unknown network, just forward it to the ISP router, and you got a specific command syntax for that as well. Okay, the command syntax goes like this. Okay, so again, let's say, only to show it to you, I'm just editing this one. So let me delete this command here. Okay, the default root command is like this: IP root 0.0.0.0 then the next hop IP, or you can give the exit interface, whatever you want you can give it. Either you can give the next hop interface or you can give the exit interface, it doesn't matter. Okay, so suppose I'm giving the next hop interface 20.0.0.2. Then the command will be do show IP root. You can see S here, it means static routing. You already know about the S, that means static routing. And star here means you got a star here, star. The star here means the candidate default or the default route. Okay, so whenever he gets a packet for 1 dot network, 2 dot network, 3 dot, 4 dot, 5 dot, 6 dot, whatever is the network, he'll only forward it to 20.0.0. So this is the default routing. Okay, in case of any unknown network, forward it to 20.0.0.2. Any doubt? Clear? Okay. Now, so here again you can see one more thing. Gateway of last resort is 20.0.0.2 to network 0.0.0.0. That means if at all say any packet has come and it didn't have a value in the routing table, then the gateway of last resort, as a last resort or as a last solution, just give it to 20.0.0.2. In case of any unknown network, just give it to 20.0.0.2. That's it. I suppose you got it. Now, shall I give you a homework question? Again, I know it's a lot for you, right? I've given you, say, a homework for the exit interface, right? Now that again, I've given you one more thing. Say what is it? The next hop address. Okay, and shall I give you or not? Or do you want me to give tomorrow? Now. Okay, I can give, no issues. Okay. Now, so you can note it down. So the homework for the default routing, and I'll tell you what to do and all, no worries. Okay, so suppose this is R1, or say you got multiple devices here, guys. Okay, so guys, let me give that 23.0.0.0 slash 30 13.0.0.0 slash 30 34.0.0.0 slash 30 35.0.0.0 slash 30 1.0 slash 24 168.22 dot. Okay, guys, again hold on a moment. Shall I explain? Now, of course, I know it is little tough for you. Okay, it is, of course, it is a little tough, but when you do it, it will be interesting for you. Okay, first give the IP addresses. You got 5 routers here. Okay, and see here you got a middle router, sorry, not this one. So here you got R1, R2, say R3, R4 and R5. Now, so here R1, R2, R4 and R5, they got a LAN here. Okay, the LAN here I've drawn it because I don't want to make it again say dirty. Okay, dirty in the sense say like again a switch, again some computers, it will say make you confused. Okay, so here I've just drawn it, so you have to take a say what do you say, you have to take a switch and maybe one computer, that's enough. So here now this IP or this network is one. So here R1 has got a LAN 192.168.10 dot network. Sorry, 192.168.1 dot network. R2 has got a LAN 192.168.2 dot network. R4 has got a LAN 192, let it be 192.168.4 dot network. Okay, 4 dot network. And this is 192.168.5 dot network. These are the LANs. Now here for R2 to R3 connection, you got a network called 23.0.0.0/30. Here you can assign the IP.1 and here you can assign the IP.2. Here between R1 and R3 you got 13.0.0 network. Here you can assign .1 and here you can assign .2. And here you got 34.0.0.0. Here you can assign .1. Here you can assign .2. And here say 35.0.0.0. Here you can assign 1 and here you can assign .2. Any doubt so far? Giving the IP addresses. Fine. Okay. Now, so now let me just tell you the next thing. Now that we'll do the routing. Now we can do the default routing in R1, R2, R5 and R4. So my requirement is that say the computers in 192.168.2 dot network should communicate to 1 dot here, 192.168.1 dot, 4 dot and 5 dot. Again 192.168.1 dot network should communicate to 2 dot network, 4 dot network and 5 dot network. All the LAN machines should communicate to each other. So here when they are trying to communicate, 192.168.2.0 is trying to communicate to other network, the packet will be sent to this R2. And R2, whatever be the unknown network, whether it is 192.168.1.0, 4.0 or 5.0, it should forward to this R3 only. So that's why I told you to do the default routing in R2. Whatever be the unknown, just forward it to this IP, which is 23.0.0.2 here. You can configure the default routing in R2. The same with R1. So whenever R1 receives a packet for 192.168.2.0, 4.0 and 5.0, say he can send the packet to this one. Instead of mentioning the 3 individual networks, you can mention it as a single default route. Clear? Again, the same thing for R4, define the default route towards this one. For R5, define the default route towards this IP. Okay, now for R3. For R3, don't define the default route for now. Okay, define the static route. For R3, which all networks are unknown to R3, 192.168.1 dot network, 2 dot network, 4 dot network and 5 dot network. So that you can mention it statically. Okay, statically in the sense, in R3 you can mention to go to 192.168.1 dot network, say forward the packet to this interface. To go to 192.168.2 dot network, forward the packet to this interface. To go to 192.168.4 dot network, again send the packet to here, and 5 dot network send the packet to here. So 4 unknown networks individually you need to mention it in R3 but not in any other device. Got it? This is how you need to do it. Okay, and again remember my requirement, all the LAN machines should communicate to each other. Okay, yes. So now you can note it down. Yes.
Yeah, yes, sir. My meeting has started. I'll leave and I'll make it up with the recording from here. Okay.
Sure. Okay, no worries.
Okay.
Okay. Need a break?
5 minutes.
Sure. Okay, guys, then we'll come back after a break. Okay. It's 13, we'll get back at 18, 19, we'll get back. Okay. Yes. 9:90. Okay. Okay guys, I suppose everyone has come back, even the online students might have come back, I suppose. Now, okay, we'll start. Now the next concept. Okay, the next concept is or root lookup. You can write the heading root lookup. Root lookup process. Okay, now guys, suppose that we got connections like this. You got R1 and you got R2, you got R3 and you got R4, and here okay, R4 has got a network 10.0.0.0/24. okay, now R1, suppose this is serial 0/0 and this is serial 0/1. okay, in R1 can send the packet to 10 dot network using two paths, right? So he can send the packet via the upper path via serial 0/0, or he can send it via the lower path serial 0/1. okay, now so here if you want to send the packets via the upper path, you can define the command like this: IP root 10.0.0.0 255.255.255.0, then the exit interface is serial 0/0. Or if you want, you can give the next hop address also, which is the IP address of this router. Clear? Okay, now that I'm going with this exit interface. Okay, now if you want to send the packet via serial 0/1, then you will give the command like this: IP root, the command is IP root 10.0.0.0 255.255.255.0. Then instead of this one serial 0/0, you will mention serial 0/1 here. Everyone fine? Okay, so if you mention only the first command, the packets will be sent via the upper path, and if you mention only the second command, then the packet will be sent via the lower path. Now what if I mention both together? No, it will send in both the directions, of course. So that is called load balancing.
Load balancing will happen.
Yes, load balancing. Okay, so that means if you have some, say 200 packets to be sent, okay, sometimes say 150 packets will be sent via the upper path and 50 packets will be sent via the lower path, or sometimes 175 packets will be sent and 25 packets will be sent, or suppose 100, or again 50, 150, like this.
So it will divide.
Yes, it will get divided. The packets will get divided, and that's called load balancing. Okay, now again one more thing. Suppose you got a computer here. You got a computer or you got a server here which has an IP 10.0.0.100. Which got an IP 10.0.0.100. Okay, now suppose only this route is there. Only the upper path is there. Sorry, just give me a minute. Okay, suppose only the upper path is there. Okay, if only the upper path is there, then let me tell you, so the packet will be sent via the upper path. Okay, all the packets, or say the packets destined for all the machines to this 10 dot network will be sent via the upper path. Now suppose I'm mentioning a command like this: IP root. Okay, so if I want to send the packets to 10.0.0.100, I mean the server, I want to send the packets to 10.0.0.100 server, and then it should be sent via serial 0/1. Then I'll give it like this, say IP route 10.0.0.100, then 255.255.255.255 serial 0/1. Getting it? Yes, that means I'm here defining, or I'm pointing to a single IP address here. Here I've defined it as a single machine, 10.0.0.100/32. Getting it? So any path which has got /32, or the subnet is /32, the prefix length is /32, this route is called host route. It's called host route. To that particular host, if you want to send something, or if you want to send a packet to that particular host, then you will mention it like this. The command syntax will be like this. Getting it? So now when you mention the command like this, so if the router is receiving a packet for this server, he will send it via serial 0/1 here. Getting it? Because I mentioned the host route here. Okay, now what if it receives a packet for 10.0.0.99? Yes, if it's 10.0.0.99, if a packet is received for 10.0.0.99, this will not be matched here. The router will look at, say, the entries, so this will not be matched here, only this will be matched. Because here I have only talked about a particular machine which is 10.0.0.100 alone. Getting it? Okay, now let me just tell you. Okay, so here it will not be matched, and it will be matched here, and the packet will be sent via serial 0/0 or via the upper path. So my point here is that whenever, say, the router receives a packet, he will check for the host route first. He'll check for the host route first, or say the path with the greatest prefix. He'll check for the host route, or he'll check the path for the greatest prefix, which is /32. Then he will check for the lower prefix, which is /31. Then he'll check for the lower prefix /30. Then he'll check for the lower prefix /29. Then /28, /27, /26, /25, /24. Here it is matched. Getting it? So whenever the router receives a packet, at first he is going to check whether he has a host route or not. Then if he has not got the host route, then he will check for the lesser prefix length. Clear? Everyone fine? Okay. Now, so it is as similar to this one. So let me now tell you an example here to make you understand, say, the thing. Okay, you might have understood, but still. Suppose if you want to go to, say, again, I'll go with the same example. Say, suppose I want to go to Taj Mahal. So this is the Taj Mahal. Okay, if I want to, so suppose that I'm in Delhi and I want to go to Taj Mahal. Okay, now consider that you only have bus to go. The train, or the, say, whatever the train is there, it's left. Okay, now, so you went to the bus station. So first you will be checking for the bus to Taj Mahal itself, for that particular place, right? Taj Mahal. If you do not have a bus for Taj Mahal, then you will check, or you will go to the, yes, you will check for the bus in Agra. Okay. Then if you do not have the bus to Agra, then only you will be checking, say, suppose, okay, then you will check for the bus in UP, the bus going for UP. So if you have the Taj Mahal bus, then of course you will board that bus only, right? So at first you will check for that particular place. Okay, that particular, so here I meant this one by, say, it will say the routers will check for that particular host or the host route. That means /32. Then it will look for the lesser prefix length or the lesser specific path. Okay, so /31, /30, like that it goes. Getting it, guys? Are you able to correlate with that example?
Yes.
Yes or no, Srikanth? Okay, Kevin.
Yes, sir.
Yes. So again, Srikanta. Yes. Okay. And there.
It is always looking for the highest prefix first.
Yes, that's it. Okay.
If it is not there, then they are lower.
We'll check for the lower ones. Okay. There again, I forgot your name. Naresh. Yes, Naresh. That happens. Okay. Now. Okay. Now, guys. Now, let me tell you. Where is it? So, okay, just give me a minute again. Now let me tell you one thing. So here, okay, now here you got the roots like this. Okay, so here you got a root for 10.000/24. Here also 10.000/24. Okay, one says 0/0 and the other says 0/1. That means here you got same prefix length here. Okay, when you check both the cases, say what is the prefix length here? 24 in both the cases. Okay, so 10.000/ say 255.255.255.0, it's /24, and here also it's /24. Okay, now whenever the router receives a packet for 10.000/100, it's gonna check whether it has got a host root or not. That means /32 is present or not. Do we have a host root here? Now, no. Then it will look for /31. Then it look for /30, /29, /28, /27, /26, 25, 24. And in 24, you got how many roots here? 2 roots. If you got say 2 roots for the same prefix length, then I told you that it will get load balanced. You'll get load balanced. That is where it will get load balanced. Getting it? Now, it'll get load balanced because by default the static root has got a value called 1. By default the static root has got a value called 1. Both the value, for both the static root, the value will be 1 here. Okay, if I change this value to 2, if I change this value to 2, then only through this path the packets will be sent. The command
Laser value will be preferred.
Yes. So again, let me tell you. So I can mention it like this. This can be the first path, and this can be the second path. Okay, so defining this value. Okay, so this value is called the administrative distance value. What is it called? Administrative distance. Administrative distance, or it's called AD value. So again, let me tell you, if you got the paths for the same prefix length, that means the prefix length here is /24. Okay, you got the paths for the same prefix length /24. Then they will check the administrative distance value, or they will check the AD value. The path with the lesser AD value will be considered first. Getting it? Now, if the AD value is same in both the cases, then they will load balance. Clear? So again, let me tell you, whenever the router receives, the router will be checking for the greatest prefix /32. So if you got, say, then only they will check for, if at all they do not have the /32, then only they will check for the lesser prefix. And again, if they look for the host root, if at all you have 2 paths or 2 or more paths for the same prefix length, /32 or /31 or for /30, you got 2 or more path, then the best path will be selected based on this administrative distance path. Okay, so the path with the lesser administrative distance is selected. Clear? Everyone? Now, in case if the administrative distance is same, then they will load balance. And by default, the administrative distance will be 1 for by default for the static route. I can show it to you here when you take this. Okay, so here I have implemented, I show IP route. I have implemented the next hop. So sorry, I have implemented the static route using next hop. Show IP route. So you can see to go to 10 dot network, there is, you can go via 20.0.0.1 and you can see one value here, it is 1. That means the administrative distance value is 1 by default. Any doubts? The 0 we'll study later. Okay, it's not relevant for now. Okay, now that you have to take a look at this one only.
If I want to change it.
If you want to change it, the command syntax is like this. Say do show run pipe section IP route, you will type the same command here. Okay, the command syntax, sorry. Okay, then so the IP route, unknown network address, then the subnet mask, then the exit interface. No, sorry, not the exit interface here. Here it is next hop address. Yes, after the next hop address, you can put a question mark and it will show this value 1 to 255. You can give it. So if I give the value as 100 and do show IP route. Okay, so here you can see the value has changed to 100 here. The administrative distance has changed to 100. Clear? So this is how you will customize the routes. This is how you will customize the routes. Everyone getting it? Okay, again let me tell you same thing, one more thing. Okay, I mean not one more thing, the same thing only. So to customize it, if you have multiple paths to reach a destination, if you have multiple paths to reach a destination, the router will be first looking for the highest prefix length. Okay, so for /32 it says, say 30.0.0, say suppose 100 machine /32. Okay, it says go via the upper path, then it will go only via the upper path. Now for /32 itself, if you got two paths, if it's /32 itself you got two paths. Okay, by default it will get load balanced because by default the administrative distance value is 1. Again, if you want to customize, you want to only go via the upper path, you can give lesser administrative distance here, 100 here and 200 here. Then it will go via only the, say, the lower administrative distance path. Getting it? Everyone fine? Again, I'm asking it because this is, there are chances that you will get confused with this one, these logics. Clear? Naresh, Srikanth, Kevin, Satish. Okay, there. Okay. And online guys, Srikanth also fine, I suppose. Yes. Ajay,
Yes, sir.
Nakshit, Nikhil, Vijesh.
Yes, sir.
Okay. Yes. So this is the route lookup. Okay. Now, do you want to continue or wind up the class? Because we had more than enough. Okay, we have studied, say, the static route. So what happened was I took faster. Right? Did you feel it?
I felt.
Felt it? Okay. No worries. If you're comfortable, then well and good. Okay. We studied the static route and say static route itself we have studied two things. Right. We have studied the next hop. Sorry, first we have studied the exit interface. Okay. Then we have studied about the, say, next hop address. Then we have studied the default route. Okay, default route, either you can go with the exit interface or you can go with the next hop address. Then I have taught you the route lookup. Okay, so this is the static routing and the routing logic and the route lookup. So tomorrow we'll go with something called dynamic routing. Today I don't want to push some more things to your mind. Okay. Yes. So let me stop recording.